Everyone, today we are going to see about sign preserving property. This is the repeated university questions, and f be defined on an interval s in r. Consider this is the r, and consider this the s and interval. We have to define an interval s in r. Assume that f is continuous at a point c in s. In s there is a point c, and we have to assume that here the point c, the function is continuous, and if f of c not equal to 0, then there is a one ball. If f of c not equal to 0, there exists a one ball, b c comma delta. That means the ball at a point c as a center and delta as a radius. This ball, there exists a ball c comma delta such that f of x has the same sign as f of c. F of x has the same sign as f of c. This f of c where arise from intersection of ball c comma delta intersection s. So intersection of c comma delta intersection s, there exists a point f of c which has the same sign as f of x. So we have to assume that f is continuous at a point, because assume that f is continuous at a point is given in the question. So assume f is continuous at a point c in s such that f of c not equal to 0. That means we since f is continuous at your point c, there exists we have a definition that f is continuous at your point. We know the definition epsilon greater than 0, there exists a delta greater than 0. Here we considered f of x minus f of c less than epsilon whenever x belongs to c, and x minus c less than delta. So whenever x belongs to s, x belongs to from value s, and x minus c less than delta. So f of x minus f of c less than epsilon whenever x belongs to s, and this can be written as the ball c as a center and delta as a radius. So x belongs to b c comma delta. This can be rewritten as x minus c less than delta. So both the values are same, the modification only different. So x belongs to the here the delta, x minus c is less than delta, and x belongs to the ball of ball c as a center and delta as the radius. So this can be, if x belongs to s and x belongs to b c comma delta, means we can replace intersection. So both value x was present, so we have to place the intersection. Both value present means x belongs to b c comma delta intersection s. For that, if we take the modulus, means what we get means this represent, that is f of x minus f of c is lies from minus epsilon to plus epsilon. So minus epsilon less than f of x minus f of c less than epsilon whenever x belongs to b c comma delta intersection s. This can be, what we do means adding f of x in all the terms, means we get f of c, adding f of c in all the terms, means we get f of c minus epsilon less than f of x minus f of c plus f of c, means the terms f minus f of c and plus f of c getting cancelled. The left term is f of x less than f of c plus epsilon whenever x belongs to b c comma delta intersection s. So we have proven this, and the next condition is f of c not equal to 0. F of c not equal to 0 means either f of c is either greater than 0 or f of c is less than 0. So first case one, we assume that f of c is greater than 0. That means we have to replace the epsilon as f of c divided by 2 for epsilon greater than 0 and f of c also greater than 0. So we know that we know the formula of f of c minus epsilon f of x less than f of c plus epsilon. Instead of epsilon, we have to substitute the f of c divided by 2. If we substitute, means we get this form as like this, and if we both are common, if we rectify, means we get 2 into f of c minus f of c divided by 2, that is 2 f of c minus f of c is f of c divided by 2 less than f of x, and 2 plus f of c, 2 f of c plus f of c is 3 f of c divided by 2, and x belongs to b c comma delta intersection s. Here the f of c by 2 is a positive and it is also positive, so f of x also positive proved. And f of c less than 0 is, from the case we have to assume that epsilon equal to minus f of c divided by 2, and here the epsilon is always greater than 0 and f of c is less than 0. That means we have to put that instead of epsilon, we have to place that here having a minus epsilon. So minus, instead of epsilon, we have to replace minus f of c divided by 2, minus minus plus. So only here the f of c plus f of c divided by 2 less than f of x, less than f of c minus f of c divided by 2. Here this is 3 f of c divided by 2 less than f of x less than f of c divided by 2. Here the f of c is less than 0. So thus so by f of c less than 0, then there is a one ball b c comma delta such that f of x has the same sign as f of c. What is the value sign of f of c? The f of x also, f of x has also have the same sign. So f of c is like greater than 0 and f of x is greater than 0. If f of c is less than 0, f of x is less than 0. So this is the, it is having a same sign as f of c in bc comma delta intersection yes as f of x. Hope you all understand, and thank you.